Okay, hello everyone. This is a review for the test, number 1. Okay, and thanks for watching. We started this year looking at measures of central tendency. All right, they describe the middle of the data, the mean, the median, and the mode, right? The mean was the average, the median was the number in the middle when you listed them in order, and the mode was the number that appeared the most often, the most frequent. We also looked at measures of spread. All right, standard deviation was variance around the mean, how things varied around the mean. We looked at the interquartile range, which is the middle 50% of the data in a box and whisker plot. And we looked at the range, which is the largest number minus the smallest number. And we looked at different displays. We looked at a box and whisker plot, which displays the 5-number summary. All right, the minimum and the maximum. And the first quartile and the third quartile, that's the box. And it clearly displays the median. All right? The exact value of the mean cannot be determined from a box and whisker plot. Not the mean, but you can get the interquartile range, which is 50% of the data. Again, there's a nice display to kind of show you what happens. Remember the quartiles, 25%, 50%, 75%. We also looked at a dot plot. It shows every value in a set of data. It shows the clusters, the gaps, and the outliers. If you want to know about an individual data point, then you have to use a dot plot. And we talked about histograms. Now, histograms, they don't show exact values, not individual values. The data is organized into intervals. And each bar in the interval displays how often or the frequency, the number of times a data point occurs within that interval. All right, if you need to know about an interval, use a histogram. Again, histograms do not display individual values. So you cannot determine the exact minimum or maximum from a histogram. And you cannot determine the exact mean or median from a histogram. Not exactly. But histograms are a good way to display the shape of the data. Now, when the shape is symmetric, it looks like this. Both tails are the same size, same length. Half of the shape is close to a mere reflection of the other half, okay? The data values, they're evenly spread out. The mean, the median, and the mode are together in the center. Sometimes data has a tail like this. It's called skewed. Right? It's unevenly spread on one side versus the other. All right, one tail is much longer than the other. And the skew goes toward the tail. So the direction of the skew follows the direction of the longer tail in the data. And when that happens, the mean is pulled toward the tail, away from the median. Right? The mean is pulled toward the tail further than the median. When a data set, all the data occurs about the same frequency in a set, like when we rolled one dice. The probability of getting any roll is the same. Right? When it's about the same, it's called uniform. And when a set of data has two modes, it's called bimodal, and that normally goes to either side. All right, it's shaped like a U. Okay. We also talked about a normal distribution. When it's a symmetric bell-shaped curve. And a set of data that looks like this is normally distributed. You notice here you have 1 7, 2 8s, then 3 9s, then you have 4 10s, that's the middle. And then it goes down again, 3 11s, 2 12s, and 1 13. When the set of data looks like that, it's normally distributed. Now, when a set of data is normally distributed, the most useful measure of spread is the standard deviation. All right? It's a measure that shows how data spreads from the mean. And again, the mean is the average. Normal distribution, again, a bell-shaped curve that looks like that, shows how data varies randomly from the mean. Half of the data is below the mean, half of the data is above the mean. All right, the mean, the median, the mode are about the same. This is a very important graphic to understand. All right, one standard deviation away from the mean. There's 68% of the data, 34% on each side, is one standard deviation away from the mean. And if you go 2 standard deviations away from the mean, there's 95% of the data right here between 2 standard deviations of the mean. All right? And that shows it right there. Again, 68% within 1, 95% within 2, and almost all of it, 99.7, are within 3 standard deviations of the mean. Okay, that's it. Guys, please complete the homework assessment in the purple folder, and then we'll have a practice test. All right, thanks.